Okay, so we're finally free from limits. Let's go to differentiation. If you want my honest opinion, well, I just want to say this. I like differentiation better than limits. Okay, so derivatives. We have various rules that we have to know. I'll just write down what it is itself. So this is called the constant rule. So it's always the derivative of any constant is 0. That's basically the idea. How about the derivative of x raised to n? So how do we differentiate that? By applying what's called power rule. It's gonna be this. So you bring down the exponent, multiply it beside the x, and then you subtract the exponent n with a 1. So constant multiple rule. So if there is a function multiplied to a constant, you might think that you have to make the constant 0, but that's not the case. Since they are multiplied to each other, it makes more sense. It is correct if it were like this. So constant would be 0, and then you find the derivative of f of x, but that's not the case here. Again, it's multiplication. So what you do, you just set aside the constant, find the derivative of the function, but technically they're still multiplied to each other. That's gonna be very much applied in partial differentiation. So that's still quite a long way ahead. We're still in my school, it's the second test, the second long quiz. Partial differentiation is still in the fourth long quiz. So yeah, sum indifference. So we have that. Just find the derivative of each term. Nothing that fancy. As long as they're separated by either a plus or a minus, you just find the derivatives individually. So yeah. General power rule. Okay. Yeah, it's essentially the same thing as earlier. But you multiply it again. You multiply it to the derivative of what's inside. The derivative of u of x. Yeah, they're both the same thing. Okay, yeah, I think that's not it. I'll be introducing another rule later as we go through certain problems. So let's try this example. Something very simple. Again, the derivative of a constant is always going to be 0. So next question. Power rule. Okay. Okay, so when you bring down 3, you multiply it by 2, so that's going to be 6. And then the cube, 3 minus 1, that's 2. That's the answer. Okay, these are two more rules that you have to know. Very crucial. So, derivative of f of x times, we'll just copy, and then plus, copy f of x, and then write derivative of g of x. You can interchange these, by the way. Some, well, at least my prof does it. So let's say this is u and then this is v, right? So u v derivative plus v u derivative. But I think this is more confusing. You just have to know this. That's basically it. For product rule. How about quotient rule? So by the word quotient, so that involves division. So personally, what I would do is just copy the denominator and then find the derivative of the numerator and then put a minus sign. Copy the numerator, find the derivative of the denominator, all divided by the denominator squared. Such that this applies such that g of x is not going to be equal to 0. Okay. Let's have an example on product rule. Okay. So essentially, this could be solved in. Personally, you don't need product rule for this. That's gonna be. There are times when you could use product rule, but it's going to be longer. Your solution doesn't have to be that long. Usually in calculus, you'd like to avoid that kind of sort because it's easier for you to make mistakes once your solution becomes, once solving a question requires you the entire page of your notebook. So you want to avoid that. Okay, right now I don't really have an example for product rule. Let's just solve this. Actually, let's try solving this through product rule. So this is gonna be f of x. This is gonna be g of x. So this is the derivative of f of x, and then just copy g of x, put a plus sign, and then just copy f of x, and then find the derivative of g of x. Now, just write down what's needed. Simplify. Is my solution correct? Let's see. Whoops. Yeah, this is supposed to be 5. But the rest is correct. This is the answer. So when you multiply this by this, the coefficient remains the same. It's still 3, not 9. Somehow my brain perceived it to be 3 times 3. That's not correct. Quotient rule. What's an application to it? Let's start with something simple first. So copy the denominator, multiply it by the numerator, which is 1, but you have to find its derivative, so it's 0, because it's a constant. And then copy the numerator, and then times the derivative of the denominator, divided by x squared, whatever the denominator is, and then square it. So it's gonna be this negative 2 over x cubed. You can rewrite that as that. So either way, technically both are acceptable. Actually, you can solve this in another way, which kind of involves reciprocation as well, what we did here. Let me show you. So you can rewrite the fraction before deriving as this. So the exponent is basically going to be a negative. And from there, apply power rule. Negative 2 minus 1 is negative 3. Same thing. Same thing. Next example. Okay. So I don't think we can factor. Maybe at least if this were 27, we could find a way through some identities. But that's not the case. Let's just use quotient rule. So copy the denominator, find the derivative of the numerator, minus copy the numerator, and then find the derivative of the denominator, all divided by the denominator squared. X raised to 4 plus 4x cubed plus 3x squared plus 6x plus 6. At this point, I think generally it's already acceptable. We don't have to further simplify. At least that's what my prof says. This is already correct. How about something like this? What if you're given this kind of question? The square root of x squared minus 5x. So when we're dealing with square root, technically there's an invisible 2 there. If you still remember your grade 8 math. So it's supposed to be rewritten as this. And if you want to find the derivative, from there it's easier because you can just apply power rule. So, by the way, negative 1/2 minus 1 is going to be, well, in other words, like this. So more clearly, you could say that it's a negative 1/2 in your exponent area. And also don't forget to find the derivative of what's inside the radical sign. So that's going to be 2x minus 5. So that's what was meant here. So yeah, that's what we use when things are more complicated to solve. So this one is not just a single term. So you get what I mean, hopefully. Even if you don't really get what I just said, you'll eventually understand it as you answer more practice questions. So 2x minus 5 over 2, and then times the square root of x squared minus 5x. So technically this is already the answer. You can further simplify this if your teacher wants you to apply, what do you call this, rationalization. Yeah, so but I'm not going to do that anymore. That's already the answer. How about the derivative of 1 over x squared minus 1 raised to 7? I'm not going to use quotient rule here. Let's solve the smarter way. It usually takes less time. So reciprocate, power rule, and then derivative of what's inside, 2x, negative 14x. So that could be the answer. Another render of the same answer is this. So either way. Okay, so we have more sample problems to work on. But I'm still thinking if we should still solve them. Maybe not anymore. I'll end the video now. But essentially I was able to teach the essentials. So you just have to practice on your own. Solve more practice questions and you'll be good in differentiation in due time. Thanks for watching.